어두운 이 밤 We need you right now 검은 밤에 갇힌 내 손을 잡아줘 Somebody home Best by 기다릴게 널 So light me up You make me shine 소중하니까 We need you now 어둠 속 한 줄기 빛처럼 너 소란은 나의 맘에 가득해서 난 너를 속일 수 없고 그런 믿음의 별들이 쏟아지네 온 우주가 빛나게 쏟아지네 매일 같지만 돌던 같은 곳에서 작은 나의 세상 So you bring the light No matter how long it takes 우리 make it away 네가 웃음을 내쉬어 어두운 이 밤 We need you right now 검은 밤에 갇힌 내 손을 잡아줘 Somebody hold the best by 기다릴게 널 So light me up You make me shine 소중하니까 We need you now 난 빛나는 것보다 영원한 걸 찾아 너란 존재가 내겐 그래 We need you right now Cause we know right now 숨을 내쉬어 어두운 이 밤 We need you right now 검은 밤에 갇힌 내 손을 잡아줘 Somebody hold the best by 기다릴게 널 So light me up You make me shine 소중하니까 We need you now 너를 보여줘 We need it now 전부 말해줘 내게 now 기다릴게 널 So light me up You make me shine 소중하니까 We need you now
Trivial to get through most of the game. Which makes me worry about the final boss. If they give you this weapon and then there's a boss, it's going to be a boss that's hard even with that weapon. Which game was it you got where you got some...
What are you doing, you
upgrade
strange
which I
machine?
find
Oh, I want
things
output
fall around
capture.
you with shot bullets.
Let's just fiddle with that. Right, now you've got the sound working properly. Right.
One of our games, you could-
I do apologise for that. Anyway, welcome back. We're in Avalon City, and we were halfway through building our kelp harvesting robot, or rather, the control circuitry for our kelp harvesting robot. Excuse me, my mouse buttons are being unhelpful. Thank you.
Yes, I think that was a wide character.
So, how far have we got? Can anyone remember what we were doing? Oh yes, we had like one tiny feature it got wrong. But that was probably going to involve redesigning half of it. Which means I'll need to, like, there, that did pretty well, except there.
I mean, this is the kind of thing that happens in real software all the time. You know, it looks perfectly fine, and then there's just this one fiddly corner case.
Yes.
And you can't even identify it quickly.
Oh, I need to go and get a tissue because my nose is running because it is now cold. Which is like good in most respects. Right. Hello again. Yes, so we have this fiddly corner case, and the fiddly corner case in question is that we don't mark when we harvest something, and so we can try to harvest the same square twice. Because if we happen to be passing over a square that needs harvesting, that's on the harvesting queue, we'll harvest it, but we won't remove it from the harvesting queue. Right. Noises.
Listen to the comedy stoke noises. I try and stand up. Also, when I walked back from the opticians today, I got bitten by an insect.
Well, it happens. Right. So.
I'm not happy about it.
So how does this thing work then?
No.
So yes, the queue we maintain in the RAM there.
Go to the loo and get my own water.
And So I could have left myself some comments here.
See, you should always comment your code, kids.
Yes. But it's kind of painful because you don't actually want to write the comments in the code because that costs you valuable space.
But you need to write your stuff.
So you get free post-it notes. Also, I've just realised, as is often the way, I've not actually moved IRC, but I don't know that anyone's going to be making comments on IRC this time, so we'll see. Anyway, right, so how does this work then?
Do you want more tea?
No thanks. So we have three things connected to the RAM. That one's connected to the radio, so that's presumably the one that receives things from the radio and writes them to X3, which is the data port of the RAM. And it then stashes in its accumulator the location in the RAM that it's working on. So yes, as I recall, this. Hang on. So we've got three things that read the RAM. So yes, this is the one that issues the movement instructions, and this one sweeps the RAM in order to check for whether we need to harvest anything. And the problem is that ideally this one would also blank out the RAM cells when we successfully harvest something. But notably it has 0 space left in its program. So possibly we need some means for it to signal some other processor that it needs to wipe something, or do we need to tighten the code enough that we can fit in some extra instructions? So what does it do at the moment? Oh, I've remembered. On like Monday or maybe Tuesday, I worked out the correct solution to this problem. Just involves a radical redesign of the entire system. More importantly, it involves a radical redesign of our data storage. Because at the moment, we're storing each set of coordinates as 2 successive RAM cells, with the X coordinate followed by the Y coordinate, which it makes it nice and easy to read and write, but does mean that any comparisons are actually quite painful. And frankly, reading and writing is a bit painful because you need multiple instructions to read and write each element. But we're dealing with 2 numbers that range between 0 and 9. So we could perfectly well record each pair of coordinates as a single RAM cell containing a 2-digit number, which would make a lot of our operations much simpler. In particular, it would make comparisons very simple because that's now just a single instruction rather than the 3 instruction mess we currently have. So yes, where is our comparison? I can't remember. It's somewhere around there. It'll be that bit, I think, that T followed by a TCP followed by a conditional jump. Is it? No, I'm not sure about that. Maybe it's something else. Anyway, but still, it's... And similarly, checking whether a pair of coordinates is 0 is 2 instructions. And so if we were to reduce all of our encodings to a single, to one number rather than 2, then a lot of the code would get shorter. There is, I think, an exception in that either this bit that decodes or this bit that encodes turns out to be marginally more painful. But I think this is obviously the correct approach. Though maybe I should just save a copy of the design I've got at the moment, because it kind of 90% works. Right, and then go back to this one, which we can now radically reorganize in order to improve things. So we'll want this, but this of course means that we're basically going to break all the functionality and then put it back together again. My hope is that the actual structure of the like wiring won't have to change as a result of this. We're only changing the firmware, but like I'm not entirely certain. Excuse me, the laptop is taking off and warming up my legs. I should put something underneath it. Right. So, what do I want to do? I want to start changing the code. So, let's start with the code that reads things in from the radio. So, at the moment, it does have a fairly simple bit of code. It just copies from the accumulator into the RAM, copies directly from the radio into the RAM, remembers where it's got to. It's utterly trivial. So this is one of the bits that gets more complicated. In particular, it reaches the point where it's probably going to need a second register, because this one's merging two numbers, isn't it? That may not be too hard, because at this line we already have in the accumulator the x coordinate. Which way round are we going to put the coordinates then? It feels to me like the simplest approach is the ugly one of putting the x coordinate in the units and the y coordinate in the tens, because that means I can just do a digit set operation here to directly write from the radio straight into the accumulator. Otherwise I'd need to do a mul 10 first. On the other hand, we have got a spare instruction. So might it be more polite to write things into the RAM in a sensible arrangement? No, I learnt my assembly language programming on ARM. Obviously we do it little endian. So we replace that. It's these two instructions here that we want to replace, and they want to be similarly conditional. And they want to be digit set 1 x1 mov ac x3. So then let's step through that and see if it works. So we check that, set that to 47, which is what we wanted, and write it into the RAM. Right, okay, that appears to work correctly. In one test case. Right. So that bit, we haven't, even though it's notionally more complicated, we haven't even grown the code. Let's write a little post-it telling us what the RAM contains, though.
If you wrote a program here, in general, which completely ignored all the input and just hard-coded the desired string of output, would it pass the test?
It would pass the first of the 80 test runs, yes.
Right, okay, you couldn't have drawn.
The problem is, you don't get much data storage.
Right.
So the standard RAM has 14 cells, for instance. We need to correctly generate 60 time units worth of output just to pass the first test run. and like your biggest processor can do 14 instructions. So yeah, it's quite encoding. Even the first test run is hard, and yes, there are 80 test runs for each thing, precisely to stop you doing this, and you don't get to see the second one until you've passed the first one. I'm not sure what happens if you fail a test run after the third, because I've never managed to pass the first 3 and fail a later one, because it doesn't show you much of. You just get a brief flash of each of them.
Which test run went wrong this time?
One. It's only one time unit, but it's one time unit in the first run. Let's at least have my comment be correct. Right, so now there's the tricky bits of... So this conveniently means that given a pair of coordinates, we do know it's quite easy to encode them, which means we can do the comparisons by encode the coordinates and then compare. But this section here is going to be the tricksy bit. So how does this work? This one... What does this processor do? So it waits until this processor tells it that any new packets have been processed. And then if we are... Oh God, it's got 2 different states that it saves... That it switches between based on the processor status register at the end of the... Oh God, I'm going to have to remember how this works. Right, so it does... On the initial loop, it reads from the RAM into AC and into DAT, and then does a bit of checking whether we're pointing at 0, whether it's read a null cell, and if we have and x1, that's the address. If we have reached a null cell but we're not at the end of the RAM, then go back and look for a non-null cell. Then here we have either reached the end of the RAM, i.e. we've managed to find that there is nothing in the memory at all, I think. Not that we ever seem to reset the address pointer, but that might be fine. Or more likely, we found something interesting, and then we squirt the thing we have found out of X3, which sends it to that processor. And then that signals back to us where we currently are, and we use that in order to decide whether to send it, whether to look for a new destination or whether to just keep signaling the current destination. Right. So something has to decode from 2-digit number into 2 single-digit numbers. It feels to me like since we're doing comparisons, we want to keep this in 2-digit numbers and hope that we can dismantle things here. This is probably thus going to have to go up to being large processor, or possibly we can play silly buggers to avoid that. So let's just edit this one so that it is expecting two-digit single byte coordinates rather than 2-byte coordinates. So in particular, it should not read into DAT. It should not test DAT. It should just copy the 2-digit coordinate to x3. It should not then copy the y coordinate to x3. It should not try to read a second coordinate from the movement controllers. Not quite. So it now doesn't use DAT at all, and is quite a lot simpler than it was. And like, it may be that we can make it even simpler. If we could save another instruction, then we could actually replace it with a small processor. So this, I fear, is going to get a lot more complicated. So I'm going to make myself some space by shuffling some components around a bit. So that now gives me enough room to make that a larger processor if I need to. But possibly I can push some code into this one to make it less large. So what would this need to do? If we assume we're going to leave these two processors the same, then this needs to handle splitting each 2-digit number into two single-digit numbers and sending them down the two things. So the problem is that the digit get operation only takes the accumulator as a source and only writes to the accumulator. So we have to do mov to get the data into the accumulator, digit get to get the first digit, mov to get it out of send that down one XBus port, something to reset the accumulator, another digit get, another mov. So that was 1, 2, 3, 4, 5, 6, and then a few instructions to shuffle data back the other way. 7, 8, 9. It might barely fit in a small processor. Let's see. So that's the X coordinate processor, that's the Y coordinate processor. So we'll do mov x1 ac digit get X coordinate 0, mov ac x3, mov, well, let's assume that we're going to get this one to send each coordinate twice and see if we can fit it if we do that. Mov x1 ac digit get 1, mov ac x2, mov x1 x3 ac digit set 1 x2, mov ac x1 slip 1. You're not allowed to do that.
Nice try.
So
It's interpreted as a syntax something,
hash is the comment character. There. I mean, it won't work any better, but at least I think it will not work any better. As I think we'll burble through here. And then hang with that one in. See, apparently with everything reading. But yes. Everything's ended up blocking, probably because half of the processors are expecting more numbers than the other half of the processors. So that really doesn't work. is there a way I can make it smaller? The way I would make it... There's an obvious loop here, but since we've only got an accumulator, we can't really do a loop. This, of course, would need an extra instruction or two. That's actually really simple. It's an extra mov ac x3. Right, that's better. Now we correctly get... Come on. That part not sleeping, and all the others are sleeping correctly. So that indicates that we haven't screwed... That like, our big problem is that we can't do that slip. Good. Right. But, yeah, we can't really do a loop for this, because we would need some kind of a counter. We could have this take the numbers apart, I suppose, because it's got a spare register. But that feels kind of messy. I think it's much more this thing's job to do the multiplexing and demultiplexing. So I think we make that a big processor, and then maybe hope we can make this one a small one, because this one feels more like it should be small. So what? Yes, the alternative would be that this one, rather than doing that mov ac x3, we make that dat instead. Do mov dat x3, mov dat ac, and extract the digit, and mov ac x3. But then, and then we test that against ac. Kind of work. Might be cheaper. Let's see. So we replace all occurrences of ac with dat, because dat contains our target. And then we do mov dat ac digit get 1. Oh, but we have to do another digit get there, don't we? We have to do that as a mov dat ac digit get 0 mov ac x3 So then what that leaves us with here is mov x1 x3. This is very silly. Blah blah mov x1 x2 blah blah. So communication in that direction from left to right over this X bus is done in 2-byte format. Communication in that direction is done in 1-byte format, because that balances the number of instructions we need on the two sides. Yeah, that's not nice. So let's just see if that vaguely works. The harvester obviously won't work correctly yet, but so that's now scanning the RAM. Oh yes, the reason why it has to have the ability to cope with the RAM being empty is just right at the start when the RAM's empty. So it should then send a 0 to there, and then another 0, and then those will get back 2 zeros and send those back. So now right, that appears to be more or less functional, right? So now we just those two processes are exactly the same, because they only ever deal with a single coordinate anyway. So now we just need to deal with this one. So this one receives rather messily Do those... Right, so the current situation is that these two transmit the current coordinates down in unencoded form down to here. Could we sensibly have it receive them in encoded form from this? Not without a fair amount of rewiring. Because that would slightly simplify the code in this processor. Oh well, we'll think about that later. For now it receives them in unencoded form and thus has to assemble them itself, which is a bit painful. But we know how to do that. We've got lots of code that does that. We just do mov x2, which is... x2 is wired up to the X processor into AC, and then we've changed that mov x3 dat to dst1 x3. And then we don't need to check dat. That's a check against 0. So then we mov 0x1 is resetting the RAM to point to start at the beginning of the RAM, and then we do is AC, which is our current location, equal to what the RAM says, and then we don't have to compare another thing from the RAM, so we can remove those two. And then we have something which uses TCP, which means I'm trying to be clever. So then that checks whether we've wrapped around to the end of the RAM, so that doesn't need to change at all, and that doesn't need to change at all, and that doesn't need to change at all. Right. Okay, so I think now we should have something that has precisely the same bug as the piece of code we started off with, but which has 3 spare instructions in this processor, and an idea of a way that I could probably get as another one if we need it. Excellent, right. Precisely the same bug, but with a bit of extra code available in this processor if we need it. Which we do because... Right, so the tricky problem... So if we've found a cell that contains what we're interested in, we will arrive here with a plus condition. So what we want to do at that point is backspace the memory 1 cell and 0 the cell that it then points to. And that's basically it. So that's just... And we can corrupt the accumulator at this point. So we can just go mov x1 ac sub 1. This still needs 4 instructions. Mov ac x1 mov 0 x0, which is obviously one more instruction than we have available. Right. Obviously what I want to be able to do is do like sub x1 x1 1 and just subtract 1 from x1, but I have to do this in 3 instructions. Mov -1 ac add x1. No, that's still 3 instructions. Mov x1 mov ac x1 is still 3 instructions, because fundamentally you can read quite efficiently, but writing things, the only thing that can write to a register is to an X bus register is a mov. So I said we had a 4th instruction available, in that DST we can eliminate if we can be reading our data from this X bus here rather than taking it from the movement processors. And if we disconnect from the movement processors, that gives us quite a lot of space, though probably not quite enough. Because like then we don't need these complicated connections. I mean, it occurs to me we only kind of need those complicated connections anyway, because actually we could use since these copy the same data to both X bus ports, they could actually be copying it to the same X bus port twice, which is what I plan to do up here. So, well, let's see how this goes then. We can disconnect that, and we can disconnect that, and we then don't send to X1 and don't send to X1, and that means that then, well, we can get a bit more leeway now by moving this processor to there. Not sure that helps, but and this processor to there, and we can reroute that X bus there. But that doesn't actually quite give us a route out for that in a rather familiar way. So, is there some slightly sneakier route? The problem is that these processors are kind of rather crammed together. Ooh, now that's beginning to get stupid, Ben, and it won't work. I mean, there is a way I could do this. How many? No, we haven't got. Yes. Oh God, that's evil. But it will work. Okay, what if I do this? Now, you may say that X bus port is for something completely other, but maybe we can avoid. No, that's not going to work, because both that one and that one will be listening on it simultaneously. So no, we do really want it to be that X bus. So that has the awkward consequence that we need to get 3 X buses out of this processor in a vaguely leftward direction. I mean, we can shuffle everything 2 squares to the left and then it becomes easy, I suppose. Well, except that shuffling everything 2 squares to the left is going to be quite tedious.
This is a pretty underpowered cab package. I mean, you think putting a big box around things and dragging everything 2 squares to the left ought to be...
Yeah, trying to drag a box around things really doesn't work.
Yeah.
Yes, I mean, you can do that perfectly well in KiCad, and the only problem is going to turn out to be that you accidentally didn't select one of the objects that you wanted to, and all your circuit board tracks don't connect up properly anymore. But
sure, I mean, when you drag like nearly all of it, but not all to the left, then you need to do order end work down the right hand side. But you don't necessarily have to do order end squared work across the whole circuit.
I mean, I am kind of going, I bet I could also redo I've already forgotten what's meant to connect up to what. Right, so X0 and X1 on that chip connect up to the address and data ports on the RAM. Right. Because actually we've got so much space. Ugh. Right. Only then so if I haven't screwed that up, it still works as badly as it worked before. Oh, except that someone's disconnected those two over there, so it won't work. Well, actually, it'll probably now crash in a not sleeping way, won't it? Yes. Oh well, let's carry on then.
I think so. Would it actually be easier to move everything to basically left by getting out of this and editing the text file?
Possibly, yes.
I just have to deal with the fact that in Crusaders 3, my efforts to ensure sensible growth of my kingdom also mean I've inherited someone else's war. Specifically, I've inherited my heir's war. Because my heir was at war with someone and then became not the heir anymore.
The top and bottom two halves over completely, not have that ridiculous left-hand side bridge.
Is there some?
There's a bridge and there's also a crossover halfway along. Can you keep the top two halves over complete?
Sorry, which bit? Do you mean this section or this section?
Well,
this section is, yes, it certainly feels mad to
the
me.
top half is into the bottom half on either side of that thing. So
Yes, if I just
put that on the bottom.
run that, run that one down to there and up to there, and then throw away the bridges. No, that doesn't work.
It looked to me like some way you're able to move the entire process of chips up and down from the top and bottom, the whole top and bottom of the grid up and down.
That doesn't help. I need to get two connections from this chip to this chip. It doesn't help if I put them the opposite way around. They still have to be connected together. So I can, and I can't. I suppose I can run this track one square inwards. Have I got enough space to do that? Because the problem is if I that I can't run a track in this column past this pin without connecting to it, or rather, if there is something connecting to it from this side. I can actually run it up this column, so that would solve the problem, but I still need the space outside for the other track. So yes, I can do.
You can run them both. Run that one directly, and then the outer one's down the middle, and not do anything at all. But not on the bridges. Yeah.
Yes,
Okay.
bridges of course being free.
But there are still stuff sticking out of there. Fine.
So yes, I can do that instead, which saves 2 0-cost bridges. Right, so now I can move that one left.
This one, of course, uses perspective.
do that. Hang on, what? Don't do that. And then wire, say, X3 up to there. Right, and then we have this send a second copy of Act to X1. Doesn't really matter who reads it first, as long as both of these processes read it eventually. So then we have this, then rather than mov X2 ACK DST thing X3, just mov X3 ACK, and don't bother with that. Right.
Now it should run again with the same bug.
Yes. And it doesn't. Oh, no, those are correctly moving. So that's not blocked. And I think I have to do this by stepping through the program now. Which is kind of tedious because that thing runs for a little while reading the RAM. So then it sends a 0 to there as expected. What was that? Yeah. Something happened that I wasn't expecting. Let's watch that left processor slightly more carefully. I mean, I've got spare XBus ports if I need them. Ah, yes, of course. That XBus is also used for communications in that direction. And if we're going to do that, then we obviously can't have this randomly reading from it, right? That's fine. Move that processor 1 square to the right so that we've got some space. Wire that to X0. That's kind of silly. And then have that send the output to X0 instead. Right. Right, we now are back to the situation where we have the bug we previously had. But we've removed one line of code from this processor and added one line of code to this processor. So now well, that's interesting. We fixed the first bug and found 2 new ones. Oh, because I'm an idiot. Conditionalize all of the new instructions. It was randomly corrupting the RAM by writing zeros to it where it wasn't meant to. Right, a failure on test run 10 of 80.
Right.
A spectacular failure on test run 10 of 80. I mean, it went fine for a while.
So you've had one that passed the first 1 3.
Yes. I mean, I can think of bugs that this probably still has, but I can't quite remember what they are. As in, I think there's a bug whereby it it will probably do something weird if you actually manage to catch up, but it clearly hasn't here. So the slight problem is I don't think I can force it to single step through this run. As in, if I hit reset, it'll go back to the first test run, which after all works correctly. So if I run it at very slow, does it still go wee? Oh, no, this is process number 3, of course. It goes slower, but not usefully slower. So it got a signal to process at 3.2. It moved 2 up and 3 to the right, I think, presumably, and harvested. It got a signal to move to 6.1, which meant it kept moving right. Sorry, I got my up and right confused. And moved down by 1, and then waited, and then started harvesting. And then it got sent to 7.0 and 7.1, all of which it can harvest immediately, and 8.2. And then it was expected to go to pause, and instead it started going back towards the origin. And thus missed. So, I mean, it looks like at this point the queue should have been, after getting that 8.2, that was it. So that's harvesting 3.2, 6.1, 7.0, 7.1, 8.2. So at the point when the harvesting turns off there, it has, we believe, harvested everything that it's been asked to harvest by that point. And it doesn't yet know that it's got to go to 9.3, because that doesn't happen until that point, when it makes another short move and harvests at 9.3. I kind of don't like the way the harvester turns on while it's still moving, but presumably that's a signal: harvest as you arrive there.
Well, when you want to mow a lawn, you turn the mower
It's
on
true,
and
yes.
turn to the lawn, I think.
Yeah, okay. So for some reason, after that sequence, it felt that it needed to go southwest. As though, so up until then it's gained 1, 2, 3, 4, 5 numbers. 1, 2, 3, 4, 5. So it's not in any way filled up the RAM yet. I'm now going, what is in the RAM and why then? The RAM contains 1, 1, 1, 5, 9, 9, 7, 9, 1, 2. So the RAM contains those last 5. But this thing which writes to the RAM just meant to keep advancing through the RAM. How many coordinates did we get? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Right, so the RAM has actually wrapped all the way around, hence 1, 2, 3, 4, 5, 6 are indeed, yes, the first 6, because we've actually overwritten the entire RAM once with coordinates. Right, so the RAM does actually contain what we expect it to contain, assuming that we successfully harvested up to that 4, 5 there. But for some reason we headed back to the origin there.
And that smells like there are zeros in the ground if you want to find.
Oh yes, because I said I wasn't sure the code would work correctly if the RAM is completely empty, which it is at this point. As in, every cell should now have been blanked, and the harvester has no work to do. And usually the harvester has a long... I mean, we saw in the animations, the harvester generally has quite a long queue of unharvested kelp that it's chasing and never manages to empty the queue. But in this one, at the moment when everything goes pear-shaped, it's emptied the queue. So clearly my handling of the empty queue situation is wrong. What's expected appears to be it does nothing. It sits wherever it last harvested and waits for another instruction to come in, which is of course what it does every time in the first time unit. There's no signals have been received yet, so it sits at the origin doing nothing. I suppose you might argue that what it should do, oh gods, yes, I've remembered what my code does. I think my code moves to the origin when there's no work to do, which is fine in the initial step when the harvester's already at the origin, but is not so fine at any other moment. Because the thing is that this processor has to signal to this one where to go every time step. And currently what it does is when it's moving to the when it's got no work to do, it signals 0, 0, which is fine until...
This is where my complaint is that this system is too waterfall. I want to send that specification back and say, this other specification will meet your requirements better. When I played badminton, I learned that if you have spare time after playing a shot, you return to the centre of the court. So you've got the minimum distance to travel with whatever happens next.
So, yes, so that's our problem. Our problem is that we do indeed attempt to return to the origin when there's no work to do. So these processors obviously can't help it. We can't change the code over here to fix that, because these two can't see one another's coordinates. This processor is the last stage at which we could do that. And obviously there are no circumstances under which moving to the origin is the correct thing to do, because there's never any kelp at the origin. So this one could suppress moves to 0, 0 if it knew where we currently were. But that's going to be quite complicated. So I feel that it's this one that wants to suppress moves to 0, 0. But there's no code spare in this. And like earlier I was going, oh well, we can obviously expand this processor, but that actually leads us into geometric problems. I'm not sure there's enough space to expand it. Because if we make it one row higher, it starts trampling on this bus. So maybe we can then shift it rightwards. Yeah, why is this processor so far over to the left? Yes, but actually, I mean, it would be much... Oops. Less, like, ugly to put it there, and that makes that track rather shorter. It doesn't make it quite... Oh, yes, it does... It doesn't make it quite short enough, sadly.
Can you go via the
No.
Anything onto the right again?
You aren't allowed to wire X-bus to P ports at all, even if they're idle. You can go past them.
I think, can you go from X2 to X0 by looping right underneath those two things? Through P0?
No.
Right.
And it wouldn't help anyway because I would have to do that in order to actually connect to it. If you do that, you don't connect. These pins really stick out sideways, you just can't see it. Well, more precisely, they are on precisely the boundary between the two cells.
I mean, you could, if you could do that, then you could have moved the processor chip thing one to the right again, until it was a bit weaker.
Yeah, so... But yes, the thing is, if I wanted to put this in place of that, then... yeah, that's actually not a problem now, is it? So I could. So the tricky thing is... Well, actually, let's try that, because I think then we can do this. If we use this instead... then obviously we need to reroute things a little. But we can. So, well, let's try first. I think the X-bus ports are all in the same arrangement, so I think that should fail on test run 10 in exactly the same way. But it now has lots of code space that we can... and probably quite importantly, a spare register that we can use. I wonder if there's another approach. No, these things are too clever. I was wondering if we could like send a sentinel value that meant don't move no matter what. But actually, that's quite tricksy by that route. So what we should do, but what we can do now, is we can have this one go. So annoyingly, this of course sees the two coordinates separately. Oh, maybe we should now move the splitting the coordinates back to here, because that way it doesn't. That way it can do a test, because otherwise it can do a test against 0 trivially, rather than having to test two incoming values against 0 by bouncing them via the accumulator, and that's going to be messy. So let's change the design so that this expects a single value that tells it where to go, which it sticks in the accumulator, and then it does if that is 0, then who knows what we do. We'll write that bit of code in a moment. If it's not 0, then we'll stick that in DAT. So DAT currently contains...
This is where I keep wishing you could do more of X1 DAT.
Yes. Well, yes. I should introduce you to TIS100, which has the inverse feature that it has no processor status registers. All of its conditional instructions act directly on the accumulator. Which is, I think, is at least a more entertaining thing to code. Oh, and the only conditional instructions in the TIS100 are jumps.
I mean, flagless is a respectable minority thing for ages.
Sorry?
Flagless has been a respectable minority choice for ages. And it's always nice to have something flagless around, just to keep everyone's code generators on their toes and make sure they can still handle the unusual ways of doing things. Flag is a minority thing. I am picturing now with the rainbow flag with a gap. Supports it, so that there's a hollow bit you can reach through the flag's minority.
Right.
Score.
So, what was I doing? Yes. Yes, this really could... it would be much nicer if this were more ARM-like. But it's not. So, we want... If it is not, then we want to take a copy of it, get digit 0, move that to x3, take another take another copy of it, get digit 1, move that to x2. Then we read back in, and so conveniently AC at this point contains the current coordinates. Excellent, that's just what we want. Because then all we have to do here is actually, no, we don't do that. We do carefully dismantle the it on every occasion, because obviously every cycle we have to tell these two processors where we're going. But if we read a 0, we do mov AC, which from the last cycles contained the current coordinates, dat. And when we start up, AC contains 0, which is correctly the current coordinates. I don't think, yes, which does actually turn out to matter, but it doesn't matter very much. Right, I reckon that'll work, except I now need to recode this, because it now needs to send a single byte form of the coordinates. So that obviously simplifies things a lot. That becomes mov dat x3 and then tk3 dat. Right, let's try that one. Harvesting kelp correctly. Still harvesting kelp correctly. Third one also works. Ooh, we still fail in the 10th one, but differently. Excellent.
So it got past the moment where it should have done nothing, and it did do it.
It correctly did nothing.
But then it failed to do something.
Ever again.
Yeah.
That's interesting. Okay, why did it do nothing ever again? Ah, so that's now a bug in the queue processing. Because the queue processor will have sent 0, 0, and then we'll be waiting for the kelp harvester to move to 0, 0. Which it will never do, because the kelp harvester knows that it's not meant to move to 0, 0 ever. So what we need to do is to say, if we were trying to move to 0, if we were trying to move to 0, 0, pretend that every destination is acceptable. So we compare, first test if the current location is our destination, and if it isn't, then we also check whether 0 is our destination. And if it is, then we treat that as a successful move. Right, let's try that. Failed on test run 20.
Oh! Good grief. This one's pretty.
So, did this ever end up idling? I'm just wondering, can I like say, so actually let's look at what's in the RAM at the end. What was in the RAM at the end is we thought we still had to harvest 3, 3, 4, 5 and 3, 2. So I reckon that this is there. I think there is still a bug in the queue processor, in that I think the queue processor may not treat the queue properly as a queue. No, I think it should treat the queue properly as a queue. I was wondering if, but maybe it doesn't. So I was wondering what happens after the queue empties, because the radio, this thing that adds things to the queue, keeps its pointer just goes round and round and round and round, and So I'm slightly worried that the queue processor might end up being confused about where it should be reading from next. But I think that should be fine, because as long as there's something in the queue, this will just keep advancing. The queue processor will keep advancing and catch up, and at worst catch up with the radio. And if it does that, then it'll reset back to 0. Oh, hang on. I think the queue processor might occasionally think that the queue is empty when it isn't. Because the means by which it detects an empty queue is if it reaches the end of the RAM without finding a non-zero value. But it doesn't necessarily start that search from the beginning of the RAM. Oops. So I reckon that's our problem, and it needs to. So the problem is that it does. This loop only loops around until we reach x1 equals 0, i.e. we've got back to the beginning of the RAM. But in the case where the RAM is completely empty, that's not, in the case where the RAM isn't empty, rather, that isn't necessarily the right place to stop, because there might have been something interesting earlier in the RAM. So what we need to do then is either remember where we started the search, or search until we reach the end twice. Remembering where we started is, I think, safe. I'm just slightly worried about what happens, whether we pick up reading in the right place if we do that. But if the RAM's completely empty, then at the next cycle there will be at most one entry in the RAM, so it doesn't matter where we start searching for it, because we will obviously find the correct entry because there is only one. Right. So it doesn't matter where this search ends. So one crude approach would be, we're not actually using ACK at all in this processor. Stash the starting value of x1 in ACK. Stash the starting value of x1 in ACK, and that's the thing we test against. So we do something like, why are we doing, oh no, because we need it, yes. So we do something like mov x1 ACK there and teak x1 ACK there. And that's added another instruction, and we use an entire register just to remember where we need to loop back to. But we still fail on test run 20. Interesting, it's not that bug.
On 20 this time?
20.
So you got past 1K?
Yes.
What? Okay.
That was the previous bug fix.
Okay, right, fine.
So this turns out not to be the bug I thought it was. Curses. So, do I undo those? Well, those changes don't seem to have made things any worse. And I think they've made the program more correct, though I'm slightly worried that maybe it was actually correct already. So... No, I didn't want to reset that because I want to actually see what we did, because we managed to work out last time. Well, we can't single step through any of the test runs after 1, I think. After 3, sorry, I think. Oh, apparently we can if we're careful. Can I now just advance through test runs 8 and 9? Apparently I can. Right. If you can manage to hit pause at the right moment, or presumably find a unique condition and just stick a breakpoint on it. Or I suppose just stick a breakpoint at the start of time. Can we do that? Right, so this is the run that fails. Oh yes, you're right, we have to go all the way to run 20, don't we? 17. There probably is one, yes. 19. Right, 20. So what happens if I ask to insert a breakpoint there? Well, we'll check that on the next run. So 1-1 gets immediately harvested. Yes. So then we do have a demonstration of idling there. And then we start sticking things on the queue. So we're currently heading for, yes, there, 04, which then gets blanked. Possibly. So we're currently heading for 4-7, but we're going to harvest 4-5 while we pass it. And that gets correctly blanked out of the RAM. So we're currently heading for presumably 4-8. Oh, sorry, 8-4. Yes, and that gets harvested. And then 9-3. So that's all right. And then is it this step where it goes wrong? So we have a target, it's 3-3. So that the top processor, though, has just read. What's it doing? Where did it get that? Oh, it's why is it? Oh, it's found a 0. That's odd, I think. I may be getting confused here. Yes, so that's then not moved for some reason. Okay. Why did it think that was a good idea? And that's then doing its usual sweep through the RAM to see if we were meant to harvest here. And once that one sleeps, we should then advance time and we will should get an error. Yes, right, good. So the bug was that it didn't move when it should have moved.
How does this ring buffer work again?
I don't know. Give me a moment. So if we drop... Let's drop a breakpoint just before there. And remove that breakpoint. And then see if we can just go... simulate. And expect it to breakpoint. Right, we can actually drop a breakpoint in an arbitrary test, it looks like. Yes. So
So at this point, the pointer on the left of the RAM is the...
should be the read pointer, and the one on the right alternates between being used by these two processors. This one stashes where it thinks it should be, stashes the right pointer in its ACK. So the right pointer is actually at the second element of the RAM.
So why is there a 0 between the 33 and the 39 and 33 then?
That's presumably where we've wiped out that 6.5. Because, I mean, we could play from slightly earlier, but that it should contain 39, 56, 33. So those three elements, those two are in the correct positions. And our current destination should be about... So
I mean, the read pointer is going to have that 0.
yeah, why? I'm just going. Why is the read pointer pointing at 39 when surely we've passed that?
Well, no, 39 is the one down right there.
Yes, but thus this should have read that because it should know that we're going there, surely, because we're still going there. We've been going there for a little while now. Let's put a breakpoint earlier
Before 39 gets put in the buffer.
and see how that does. Right, so the 39 hasn't arrived yet, and now it's about to arrive. So that's the right pointer being reset to where it needs to be to actually write things because it's shared. And then it gets written. So now the reader is several steps behind and has left this 7.4 kicking around. What's that doing there? Like 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's in the right place for us to have reached it on the first pass.
So the read pointer's gone past that. It knows we're heading for it. It's about there.
You're right, of course. Thank you. Precisely what I told you about last time. Yes. The read pointer, of course, points one beyond our current destination. Because the destination is about to be... Indeed, this thing is about to send the destination again. And then those are going to instruct that move and assemble a 7.4 which says we're about to get there. And then the harvester is then going to conclude that we're somewhere interesting. It then resets what is usually the right pointer and sweeps through the RAM looking for 74.
Oh, so that thing that says, are we back? Right, there's only one choice of how to harvest. Is there anything in the RAM around it?
We find the 7.4, we harvest, we remove the 7.4. Right. And that's done the harvesting. So now the radio receiver does a bit of faffing. And now we should head... So now the Q reader should go, oh, there's a 0.
I'm suspicious if these 3 things are alone. Confusion.
So it reads that 0 into dat, checks if it's 0. Since it is 0, we... Hang on, TGT? What are you on, Harris? That's not going to work. I think. No. Checks if we are beyond... It checks if we have... This is intended to be check if we have just wrapped around. As in if we have read every cell looking for a 0. But I think that GT was fine as long as it was testing against 0. It's not so good using GT as a substitute for NE when you're testing against a non-zero value.
So actually the point was that you wrapped around looking for a 0.
Well, so, but I don't think that's going to make any difference because x1 is going to be greater than AC because we are one step beyond where we started. So we will go on to the next thing and find that it's non-zero and correctly process it. But thus... So I think we can safely run time on a couple of steps. So we correctly move to this square.
So 6-5 just appeared.
And we immediately harvested it.
It was the square we were going to step onto anyway.
Yes, but we've done the right thing. It's been blanked from the RAM. We harvested. And that was what we were expected to do. So that was writing into that.
So I'm still suspicious of the fact that after that 39, we're going to have to skip over the 0, but it happens to be at the very end of RAM, come back round.
Yes.
And that thing that says, have we just wrapped round?
Yes, well, it's obviously incorrect, is the thing. That code is blatantly wrong. I mean, we can try to prove why it's wrong.
In real time.
So we're continuing heading for 7.5, which means that we do so that then searches the RAM, finds that there's a 57 in there, and so activates the harvester for this move. Erases 57 because we've correctly harvested it. So then that adds 33.3 to the so yes, now we're heading for 8.4. Which will be fine for one step. That searches the RAM for 8.4, A48. Enables the harvester. Wipes 48 from the RAM. So next that should read 339. There it goes. Direct us to 39. Fish 39 out of the RAM. There is actually a bug that Yes, there is a stupid bug that we haven't. I've just spotted another bug that we haven't yet encountered. Excellent. I don't think we can. Hang on, what? I was going to say I don't think we can correctly blank the last element of the RAM, but I think we have done so.
Yeah, that was one we didn't see happen because it.
Yes, but I depend on being able to read the current address sub 1 and write it back again. Clearly, the RAM works mod 14.
That's convenient.
Nothing else in this thing wraps around. Well, I suppose the RAM pointers wrap round when you hit the end anyway. So it's reasonable that it should work mod 14. And I think the RAM does come from a different manufacturer from the processors. Right, so then everyone sleeps and we advance to the next time step. And now is when something goes wrong. So
we're expecting the read processor to skip that 0 and then read the 33.
that's the idea, yes. So at the moment we're just setting the radio works out whether it has a signal, decides it does, adds it to the RAM, and then signals to the reading processor that it should read something. So it then loads the current address pointer into the accumulator, loads DAT, discovers that it's 0, and then wants to check. And now, of course, the address pointer is not greater than the accumulator, because the accumulator is 13 and the address pointer is 0. And so we incorrectly think that we've wrapped round. Yes, so that is precisely what we... It is precisely the bug that I had already found. Excellent. So now I just need to code around that. It's rather amusing that it failed in the same place that we got the failure when it was testing incorrectly against 0 instead. But I suppose, yes, it's a wrapping thing. So what we really want is to have that be a TNE, but there isn't a TNE. So what we want, this may have to be 2 loops or something like that. I mean, we can do this actually. Like we can do, we want to go, we want to jump to Y if dat is 0 and x1 is not equal to ac, ideally. Which yes, I mean we can do that as
Minus jump Z. Sorry, X.
I mean it's crude, but do you think that'll work?
I'm not sure.
I'll hit the simulate button and see who works it out whether it's correct first. Right, here we are at that breakpoint. Right, that seems to... No, what? It's still incorrect. Right, let's run through to the breakpoint and then actually pay attention rather than just clicking advance. So, I mean, I've apparently written something that's pretty close to equivalent to what we had before. So, the interesting situation is coming up. So, we've now decided we're going to 9.3. And it will thus have... that process, the Q controller will have concluded we need to go to 9. We are at 9.3, and the harvester concludes we're at 9.3 shortly. Once it's read all of the RAM to check whether there's a 39 in it anywhere. Right, then the radio receives a new signal and writes it into the memory. And then we tell the Q processor that it needs to do something, and it... Oh, I have a horrible feeling we've screwed up the condition codes in an entertaining fashion, because I depend on the condition codes in a slightly odd way here. So it should be searching for a new value. It's doing that. Good. So it remembers where it was in the RAM. It says, are we looking at a 0? Yes. It finds a 0. So, hang on, I left that as a TGT.
Yeah,
Stoke face.
That was why I was scratching my head. I thought, haven't you just replaced it with something one instruction longer and equivalent?
So that should actually be TEQ minus jump Y. I mean, yes. Having already accidentally left that TGT as a TGT when it shouldn't have been. Right. I shall bravely just hit advance. Yes! Right, let's remove that breakpoint. Phew!
Pretty good. That's modal lines of code and better than everywhere else.
Yes. Phew. So, yes, Sun Hao Chan said, yes, please join me in warmly congratulating Dr. Shimura and her team for the success of the Ocean's Bounty Programme, which has essentially solved the issue of food production for the entirety of Avalon City. Additionally, the technology developed for this programme will make a lasting beneficial impact on all of humanity. Yes, okay, so this is a big win not only for our independence, but for the future of the planet as well. A message from Sun himself. That's amazing. Congratulations, Lisa. So, what's next after revolutionising how the world makes food? Thanks, Derek. It was a group effort, of course. To be honest, I thought about taking some time off, but Enzo is already pulling me onto another project. No rest for me. Well, if you need any robotics, you know where to find me. And we have 2 new things, which cover the last 2 pages of the manual.
Those look familiar.
So one of them is a sushi making robot. Having tasty sushi clearly wasn't a priority early on, but now that the Ocean's Bounty project is finished, I figured Avalon City could use a little more high-end dining options. I think I've got the mechanical aspects worked out, so all it needs now is your expert logic to make it run. P.S. Don't tell Lisa about it.
Why shouldn't you tell me?
I don't know.
Maybe it's actual sushi with fish and not using her kelp.
And from Irina Kurchatova, oh no, it's not the last 2, there was the neural processing lattice still to go. From Irina Kurchatova, as promised, I have a serious job for you. These will be custom displays to report the current status of each component for monitoring and control of my thorium reactors. A bit more interesting than cats, maybe.
Which one prefer, thorium or cats?
But I do actually have another specification now, because back in Shenzhen, we still have this, which is labelled with an exclamation mark, suggesting I haven't done it. Namely, create a custom specification and a working design for it. And I haven't been doing this on the stream, not least because it would involve me learning Lua live, because the specifications are written in Lua, or rather, you write a program that generates the program in Lua that generates the specification. And it also took me 3 attempts to come up with a specification, with an idea for a puzzle that I thought was halfway reasonable. But I have one, and I'm not going to try to complete it in the next 5 minutes, but I thought I could show you it. So the first 2 attempts at doing traffic lights and indeed a railway level crossing didn't work very well, mostly because they need so much damn time. Like anything that depends on timing, you end up with something that your 60 time units just disappear. But I came up with the idea that maybe we could build a printer. So, like, it's a bit like the robotics things we've had already. The idea is, and sadly we can't get a little visualization, but the idea is we have one output that rotates a daisy wheel, one output that fires a hammer that prints the thing currently under the daisy wheel, one thing that moves the carriage left and right, and one thing that advances the paper. And the input we get is a sequence of numbers, and we have to format the numbers in decimal and print them right justified in a four character field. Rotate wheel, print, rotate wheel, print, rotate wheel, print, advancing the carriage as necessary, feed the paper, return the carriage to the left margin.
I was with you until format the numbers in decimal. That's a little bit weird for a printer to be taking that on itself.
Well, I'm imagining that this is like the printing unit that you have in a little calculator or something.
Right.
But it was mostly that I thought I could have it do. I thought this would be like a small extension, because then otherwise you just have you have to think about character sets and so forth, and it's kind of a bit boring that you're just taking a coordinate and moving to that coordinate, and we've already done that. So that, of course, meant I had to write an implementation of this in Lua so that it could generate the test cases. But thus here we have a test case where it's trying to print 81, so it starts pointing so it needs to write space 81, so it advances the carriage by 2 while simultaneously rotating the daisy wheel from pointing at 0 to pointing at 9 to pointing at 8. Then everything stops while we fire the hammer, because obviously if anything's moving while you fire the hammer, unhappiness will occur. And then we advance the carriage by another 1, and we rotate clockwise. We rotate forwards from 8 to 9 to 0 to minus to 1, and then we print the next. When we fire the hammer again, and then we advance the paper and carriage return to the left margin and wait for the next number. And the test sequence generator guarantees that you will never receive a new number until you finish printing the previous one. I presume the idea is that in general this would actually be a fixed amount of time, but the test generator tries to cram in as many tests as it can, so it gives you a short pause of variable length so that you can't go and guess how long the pause is going to be. And then we print the next one, which involves move forwards while rotating to I hope this is correct. Why are you rotating backwards 2? Oh, because of course we're pointing at 1 at this point, because we've just printed the 1, so you rotate backwards to 0 minus, printer minus, rotate forwards to 0 1, printer 1, carriage return, and so forth. So that is a challenge that I have no idea how I'm going to solve, because I designed it as something that felt like it was feasible. You will notice I've made the circuit board as large as is possible, because I didn't want to go discovering that you can't implement it in the space available. I've spaced the outputs out nicely so that they should be fairly easy to wire up.
But it's noticeable that this circuit board as large as possible is still considerably smaller than the one you got for the sun.
Yes, indeed. So possibly next time I will attempt to solve my own puzzle, because we are missing one solved puzzle in that we have to solve a puzzle that we haven't that we designed ourselves. So yes, that's the next job, and I think it should be fairly fun. And I think formatting the numbers won't be too hard, because we've got digit get and so forth. And I think
in a binary system, this solves formatting in decimal with a major headache. On a decimal system,
that's fine. All good microcontrollers have BCD support, don't they? We can probably hope that the calculator chip would feed us in BCD if we were on a because it's got to feed the display as well.
Right, and the thing that's actually doing the serious calculation, with that figure out decimal, it's got nothing.
So yes, I think this is probably not too difficult to challenge, and we will do that next time. And so it's being 1 minute past midnight. I shall say good night. Good night, Avalon City.
Avalon City goes to sleep, all its friends go to sleep.